I just found out 0, 0, 2, 0. I showed my work for him.
All right, so which one did you have a question on?
Number 4 and number 6. In regards to the x squared plus 4 equals 0.
Okay, so let's take a look at number 4. F of x is x times x squared plus 4 times x minus 3. All right, so this is a polynomial function if we were to multiply all these pieces out. And so we're going to look at the leading coefficient test first to see if it opens, like how the left and right hand sides go, right?
It's going to go like this.
Like
football.
Like a what?
Like football.
Okay, so up on both sides. So this one acts like x. This one acts like x squared. This one acts like x, right? Right? That's what they act like. So if you multiply those together, you get x to the 4th. And so it should go up on the left and up on the right. Then our step would be to factor, but it's already factored. So we set each of the factors equal to 0. This one set equal to 0, and you just get 0, right? This one you had trouble with. This one you set equal to 0, you get x is 3. Okay, this one, x squared plus 4 equals 0. That means x squared is negative 4, and that's an imaginary number.
Exactly.
Right? Okay, so what does that mean?
It means that it's a no solution?
That's right.
Okay, so I did do it right.
That means that it doesn't. This factor does not contribute to any x-intercepts
Then how does it play in when we're trying to
in the
sketch
picture.
it?
Yeah, so let's take a look. At this point, you would just go to the graph. You would just sketch it.
Because I found the y-intercept, and it just made it kind of funky.
Okay, so here's 0. You have an x-intercept at 3. Oh, I forgot to talk about whether or not we cross or touch. So what do we do here?
That's going to be cross.
Cross through? It was x, right?
Yeah.
Yeah, it was x. So just cross through over here, cross through again. Yes? And then there's nothing here from this piece. And it goes up on the left, so it goes up this way, it goes up this way, and it crosses through. So, it goes down and then does something, and we don't really know what. It can do all kinds of weird stuff. And then it comes up. As long as it's smooth, continuous, right? No jagged corners, then that's it. That's the best we can do.
Okay.
It almost looks like a parabola, but it doesn't if you graph it.
All right. Well, I found the y, which is negative 12, but it just...
Y-intercept should be 0.
Is it?
Yeah, because you plug in 0 right here, it's going to kill everything off. I think you may have not plugged in 0 here. You may have plugged 0 into those two and got negative 12. Right? If you do 0 here, you get 4, 0 here, negative 3, multiply, you get negative 12. So I think that's what you did, but you forgot the 0 out front.
Correct.
Right?
Gotcha.
Yeah, and that would be weird because then you would have you would have another point down here,
Yeah, that's...
and then it wouldn't be a function. It would fail the vertical line test. Yes?
If that middle part was x squared minus 4, would you separate it out to x plus 4?
Yes. Had this been minus, then you would have 2 other x-intercepts, and you would plot them, and it would cross.
Even or odd? Would you count like the x squared?
Good question. So if this had been minus, let's just see what would have happened. Then it's not completely factored yet. So we would have to do x plus 2, x minus 2. And then each of these factors would give us an answer, negative 2 and positive 2. And then you're looking at the power on each of the factors, so they'd be odd.
Okay.
So you would cross, and you would cross everywhere. Picture would look like,
Kind of like number 6.
it would look like that. Yeah. All right. Did you figure out the one from earlier? Sorry, I didn't expect you all to just like pick up and go, but okay. Okay, but you were good? Okay. So I'll collect those. That's going to be, more of like an effort grade. You tried it, and put some time into it. So if you could just kind of pass them like towards the center and then get them up here.
Can you do number 6 on the board as well?
I can talk about 6. But turn them in. I'm not going to do all of them for you.
Oh, also do number 2. I'm just kidding. That was a joke.
2x to the 4th. Everyone got them? Let's see. This it? Here, just set them right now. We are going to, you know how we skipped quadratic inequalities? I'm going to skip polynomial and rational inequalities. And that way, when I go back and do those, I'll do them all at one time. Okay? So we're going to start, I have a different sort of section today. We're going to learn how to factor polynomials that we can't normally factor.
Did you ever put the key for the test?
I didn't put the key. I had a reminder on my phone, and then it went off, and I was at home, and I didn't have a copy of the test.
Gotcha.
So I remembered it this morning. Yeah, it's not up. I'll put it up. Don't worry.
All right, thank you.
Anyone else? Last call? Thank you. All right, so for this one, we start off by trying to determine the left and right behavior. So the degree of this is 4. Leading coefficient is 2, so goes up, up again. In the middle, we don't know. And now we try and find the x-intercepts, so we set this equal to 0. And what would be the first step to trying to solve this? Do what?
I just factored it.
Did you do that now, or did you do something before?
Well, actually, I just did it like that, but then I realized like later on I could have taken a common factor out.
Yeah.
It still came out the same.
It should come out the same as long as you looked at your two grouping things and pulled something out of there.
Yeah, I had to pull it out twice.
Now, would it give a different answer if you just took out x from everything?
No.
No.
Would you mind doing it like that then, just to show me? 'Cause that's what I ended up doing. And I got
I'm going to do it this way first, and then I'll show you if we have time the other way. Only because I don't think anyone. Well, how many of you just pulled x out and not the 2? Just x, not the 2? Okay. Is this right? I'm pulling out a 2x right now?
Yeah.
Yes? All right. And then on this part in here, because you have 1, 2, 3, 4 terms, you do grouping. So you split it right here. And then you pull a GCF out of these two. So I can pull x squared out, and I'm left with x plus 5. Over here, what we need to do is get something that comes out that will leave us with an x plus 5. Can we make it happen?
Yes.
Yes? Minus 4, and we're left with x plus 5. So that would be the appropriate grouping factoring on that. Equals 0. Still have 2x out front, right? No questions? And then this is the part that just turned in that other thing because someone told you it did, right? Okay. So this is going to become 2x, and then x plus 5 in parentheses, and then another, what, x squared minus 4? These pieces right here. So x squared minus 4 equals 0. And we can do difference of squares. So 2x, x plus 5, x plus 2, x minus 2 equals 0. And how many x-intercepts are we going to have here? 4, right? So we have this one. You can set the whole thing equal to 0. You get 0. Here you get negative 5. Here negative 2. Here positive 2. Crossing at all of them because the powers on all these factors are odd powers. So cross, 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 cross. 0. Negative 5, negative 2, positive 2. Those are my x-intercepts. Goes up on the left, up on the right, like this. So I'm just going to back cross through at all these. That's just for fun. There we go. That's it. All right. Now you want to see with just the x out?
Yeah.
Just x. So the only difference would be pull x. We get 2x cubed plus 10x squared minus 8x minus 40. And then you did grouping here. So what did you pull out of
2x squared.
2x squared? You're left with x plus 5. Over here, minus
4. Just minus 4 and then x plus 4.
minus, it would have to be 8,
Minus 8.
right? And then this is x. Then you do the same thing here. This would become x plus 5. And then 2x squared minus 8, right? Equals 0. That look familiar?
Okay, I see what I did wrong.
And then you would have to look at this and actually pull a 2 out. And once you pulled the 2 out, it would come out here, and then that would turn into 4, and then difference of squares. All right.
Like you said, there's different ways to go about doing this. Like
That's right.
same thing.
That's right. That can be good and bad, you know. Sometimes it's good because you're going to eventually stumble upon the right answer, and sometimes it's bad because you're stumbling and you don't realize you're still okay, and you just get lost. And you know. All right. So today, what we're doing is we're going to look at a new way of factoring. So what I promised you last time, right?
Yes, we're waiting.
But there is one thing on the end of at the end of this section that I didn't do. So let's talk about this. So this example is visual. It says construct a polynomial function that might have this graph. So this is backwards from what we've been doing. I usually give you the function, ask you to come up with the picture. This time I'm giving you the picture. I'm asking you to come up with a possibility for a function here. So tell me about this function. Someone give me some information about this function.
Why the x-intercepts are
X-intercepts are
1 and 2
negative 1 and 2, right? Okay, anything else?
Y-intercept is -2.
Y-intercept is negative 2. Anything else?
You're going to have x squared.
You're going to have x squared.
Touches it or bounces
So you're touching at negative 1, right? Which means that that factor is going to have to be an even power. It's odd. Okay, so you have an odd degree. You have an odd degree because it's left down, right up. So we've got a lot of information just from this picture, right? I can say for sure that the degree is odd. I can say the leading coefficient is what? Positive, right? Because left side down, right side up. I have x-intercepts of -1 and 2. I'll get to that in just a second. I touch here and I cross here, right? And I have a y-intercept of -2, right? That's pretty much everything we can gather from that picture. So let's try and come up with a function that does this. So here's where I'm going to start. I'm going to start with the x-intercepts. I know that if I plug -1 into the function, it should give me 0, right?
Yeah.
If I plug 2 into the function, it should give me 0. So I'm going to reverse engineer that and make it x plus 1 and x minus 2. I know those two must be factors, shouldn't they? That way, if I plug -1 in right here, I get 0, and the whole function is 0, and that means you're an x-intercept. If I plug in 2 right here, it gives me 0, and then I've got an x-intercept. So far, that looking okay?
When you plug f of x 0, it also gives you a -2.
I'm going to do that last. I'm just going to adjust one thing. Right now, is my degree odd?
No.
No, it's not an odd degree, but one of these has to touch and the other one has to cross. So how can I make it touch it at -1? Square it. Square the factor. Right? If I square that factor, it's now going to touch at -1. and it's going to cross it at 2?
Yes.
Could I have made that a 4?
Yes.
And that a 3?
Yes.
Yes. That's why it says construct a polynomial function that might have this graph. Everyone can have different answers, but they all have to have the same characteristics, which are this to an even, this to an odd, right? So far I've got the odd degree, I've got a positive leading coefficient, I've got 2 x-intercepts, I've got touching, I've got crossing. The only thing left is the y-intercept. I need to make that happen. So that means when you plug 0 in, right, when you input 0, the output should be -2. Agreed? What happens if I plug 0 in right now for x?
No, it's going to be
-1, 0. This will be 1, right? And then 0 here, -2. So 1 times -2
-2.
gives me -2, doesn't it?
Yeah.
That actually works.
Yeah, surprisingly.
That's too easy. Let's change it. Let's make it -4, just to make it a little more interesting. Make it -4 instead. Just make it -4. Now does it work? No, when you plug in 0, it doesn't spit out -4. I mean, so what we're going to do is this. We know that if we just put a number out here in front, does that change anything? A number. Like if I put 5 out here or 10 out here, it will not change the degree. It won't change my x-intercepts, right? All that does is just kind of adjust what, like stretches it.
Yeah.
I need to stretch it appropriately to make it pass through this y-intercept. So watch what I'm going to do. What is f of 0? Well, f of 0 is a times 0 in here gave me a 1 times 0 in here gave me -2, right? I need that to be equal to what? -4, right? -4. This left side is just -2a, must equal -4, which means I should let a be what? 2. So if I come in here and I say 2 times x plus 1 squared times x minus 2, this function will satisfy all the conditions of that graph. Make sense? If I plug 0 in here now, I'm going to get -4. Still have the same x-intercepts, still have touching and crossing. Yeah? So that's the way we'll go about this. Start with your x-intercepts, create your factors, use the touching and crossing to look at the powers, and then after that, check your degree, check your leading coefficient, and then out here, figure out what a is from the y-intercept. You want to try one on your own? I'll give you one. I'll just draw it real quick, okay? See if you can come up with one.
This is going to be on the test.
Could be. Wait, this is too boring. That's too boring.
That's too boring, so that's fine.
Don't give us more work.
You don't need to draw this, okay? Just look at it and do what you need to do here. Okay, give me a function that does that. If you think you have it, yeah, when you get it, raise your hand. I'll come by and see if I agree. I made the problem up, so you might get a fraction for a. Just be aware. Let's see. What's the degree supposed to be, even or odd? From there, it's supposed to be what? Even, yep. Is yours even? Okay, good. Now, your factors are all to the first power, which means you're going to be crossing through, aren't you?
Yeah.
You need to adjust that. And then that's going to change how you get A.
Okay. Yeah.
Okay. Did you think you got A? Yeah. So when you plugged in 0, 9. This is multiplication. When you plug in 0, you get 5 times 9 times 1 times -2.
Yeah.
Yeah.
All right.
Looks good so far.
How would I go about trying to find, like, would I just look at essentially each of these without the x and add them all up
No.
first?
What you
Find out
need to
where
do
it's
is
at?
put, like you've got all your little factors in here, right? Whatever they are. Put an A out here. Say this is f of x, right?
Yeah.
I just need to figure out what A is so I can stretch it to get to that y-intercept, right?
Yeah, but first wouldn't I have to find out what f of 0 would be to find out where the y-intercept currently is?
You know where it is. It's -10.
No,
Right.
where it currently is as is this, so I know how to adjust it.
Yes, you will plug 0 in, okay? So you go 0 and then whatever. All of this together, right, is going to be some number. You multiply them together, right? This is some number. You know that A times that number needs to be equal to -10. All right? Just put the A in there and just figure out what the number is and you'll get it. What do you got? 1/9, okay, we'll see. I don't know. Who else has A? Anyone else think they have A? What did you get for A? I don't know what the answer is. 3, what did you get? 1/3? So I have 3 different answers so far. 1/3, okay, that's a good sign. We have 2 1/3s. Anyone else have A?
Well, it's still touching the x and 0. Don't worry about that.
What did you get for A? 1/3, okay. 1/18? Not quite sure. Okay, so look, it looks like A is where people are getting hung up. I don't know the answer yet. I need to work through it myself. Did y'all get 1/9? I've seen a couple of people get 1/9, so I'll start putting it up here. Let's see. X plus 5, x plus 3 squared, x plus 1 squared, x minus 2. Okay, I think I'm ready to talk about this. If we're keeping this as simple as possible, our 4 x-intercepts correspond to these factors, don't they? Right, it's just the opposite of the number in here. But I need to touch at these two, right? Which means I need even powers on their factors. So I put squareds. If you wanted to put fourths, it's going to change your A. Your A is going to be different than my A. But did everyone use squareds? Yes? All right. So what I know is that when I plug 0 into this, it needs to spit out -10, right? And so what I know is I'm going to scale this by some number. I don't know what it is yet, and that's going to stretch it out. Now keep in mind what we're doing here. If we adjust this A stretches the function, right? If a point is at 0, you cannot stretch it. It won't move. But if a point's here, I can stretch that out, can't I? So A, what it does is it moves this stuff down, this stuff down, this stuff down, this stuff up, but all these anchor points don't move. And what I'm trying to do is find the A that's going to stretch this down to make that point cross through. So I now come over here and I say, all right, f of 0 is, well, A, 0 in here, 5, so times 5. 0 in here, 3 squared, 9. 0 in here, 1 squared, 1. No. Remember, the x-intercept is opposite of the factor. Yeah, okay. So what else? Negative 2? Like that? Everyone see that? Now what's 5 times 9? 45 times negative 2? Negative 90. So this is negative 90a. And that has to be equal to what? We need that to be equal to negative 10. Right? We need it to be equal to negative 10.
So then A would be 1/9.
So it would be 1/9. So this must equal, I don't like the way I wrote that. I'll write it like this. This is a better notation. What I needed was f of 0 to be equal to negative 10, right? That's what I needed? So I'm going to work the left and right hand sides down like this. The left side became a, 5, 9, 1, negative 2. The right side still negative 10. So working down again, this is negative 90a, must be negative 10. And then keep working down, divide both sides by negative 90. You get 1/9. So a is 1/9. That okay? So if I come over here and I replace this with 1/9, then that would be a polynomial function that would represent that picture. All right, good. No more questions? All right, let's.
It's not as bad as you think.
I didn't think it was bad.
Well, at first when you go home, you got to figure that out.
I know. It's a lot better once you work it yourself, right? I mean, watching me is one thing, but okay. How about this one? Construct a polynomial function with these characteristics. Very similar to what we just did, except no picture. You have 3 zeros. Zeros are the same as x-intercepts. So what do you know about this function so far? What are the factors? What are some factors I can have in here, or need to have? Plus 4? Yeah. Minus 1? What about touching and crossing? I don't have any information about that, do I?
Nope.
So can I just make one of these touch if I want to? Like, can I just say, all right, I'm just going to make this one touch, make that squared. Can I do that?
Sure.
Yeah.
Well, the degree needs to be 3.
The degree has to be 3. So I can't do that because now the degree is what? 4. Do you see that? X squared, x, that's degree 4. So I can't actually do that because the degree is topped out at 3. So that's the only choice I have. But it has to contain the point 2, negative 18. That's the same as the y-intercept idea. You plug in 0, it spits out a number. But this time, instead of plugging in 0 and spitting out a number, it's plugging in 2 and spitting out a number. So I'm still going to put an a here.
But this is still the same concept.
Same exact concept. Now what I'll do is I'll do my work right underneath. I know that f of what needs to be equal to what?
2.
F of 2 has to be equal to 18. Negative 18, right? And work the left and right hand sides down. So what would f of 2 be? Plug 2 into this. A, 2 plus 4, 6, times 2 minus 5 is negative 3. 2 minus 1 is 1, equals negative 18. The left side is another boring problem. Negative 18a equals negative 18, which means a is 1. So that means that I could have just done that and I would have been there. But I had to make sure, right? I had to verify.
Because we didn't know.
We didn't know. It could have very well turned out to be 10 or something else. Could this number have turned out to be, well, it could have been negative, right? That doesn't change the degree. It's still, just would have changed this, right?
Right.
So it could have been negative. What I'm getting at is on the previous problem, could the a have been negative? No, because the way that it goes, you know that the leading coefficient had to be positive.
That's true, it didn't say if there was negative results.
It didn't say it, so. All right. We are done with sketching polynomial functions. And really, it all comes down to the factoring part of it, right? I mean, if you can factor these and keep track of the bouncing or the touching and the crossing, then there's not a whole lot of work that has to be done. But what about this? Sometimes we run into polynomials which we cannot factor using our standard techniques. So standard techniques are like greatest common factor, AC method, grouping, difference of squares, cubes, things like that, right? We have standard ways of factoring, which I told you from day one, you got to be able to factor to be in this class, right? So let's take a look at this, and let's try and sketch this. F of x is x cubed plus 8x squared plus x minus 42. So if we were sketching this, we know what it looks like, right? Left and right behavior. Down, left, up, right. So we would have no problem with that part. And the next step would just be set it equal to 0. All right, so let's set it to 0. And let's go around the room. And let's see if anybody knows how to do that. Only reason I'm asking is because I want to see if anyone actually knows how to do this or not. Did you raise your hand yet? How? Grouping?
Can't you do group?
Oh, no, I'm pretty sure I know. Like, wouldn't you just look at like all of the x's being 0 and multiply out everything would be 0 except for the negative 42? Like the first three would just be 0?
You're plugging in 0 for x?
Yeah.
That would spit out negative 42. That's a y-intercept.
Oh, I thought that's what you're asking.
No, I'm looking for the x-intercepts, right? We're trying to set this to 0. So we try our methods, right?
You can try grouping.
I already thought about that.
What's wrong with grouping? I thought we do grouping when we have 4 terms.
No, but the second is wrong.
So let's try grouping, okay? It's not going to work, but let's see why it doesn't work. Right? You'd split this, wouldn't you?
Well, we know it's
You
not
can
good.
pull a GCF out of the first one, right?
Well, I already did it.
In order to make this work, what has to be left in here? It has to match, right? These have to match. But there's nothing you can pull out of this to make this, right? You can't do it.
There's no GCF.
So there's no GCF. Grouping fails. Any other methods?
Factoring, no. And
Yeah, that's it. Like this is dead end, right?
even quadratic.
This is dead end. Quadratic formula won't work because it's not quadratic. So maybe it's like that. Maybe it's like the problem that you asked me about at the beginning of class, x squared plus 4, where we just said it didn't factor because it's got imaginary numbers and right. We just say, yeah, it just doesn't factor. Maybe that's what it is. It just doesn't factor, and so it doesn't have any x-intercepts, right? Isn't that what that meant? It wouldn't have any x-intercepts.
Yeah, because it's imaginary.
Yeah. Let's just think about that. Come on. Look, if I told you to graph x squared plus 4 just by itself as a function.
You would put the x squared, raise it up.
That's right. You would take that and raise it up 4, wouldn't you?
Yeah.
And then I come in here and ask you, what are the x-intercepts? You tell me there are none, right? And it makes perfect sense that there aren't any,
Oh, okay.
right? Makes perfect sense that there's not. If you try and set that to 0, you get imaginary numbers. The fact that we can't factor this, okay, does that mean that we don't have any x-intercepts? Maybe not. Maybe not.
Maybe we need a new factoring method.
Maybe we need a new factoring method. But see, with this problem, you would be happy with me just saying there's no x-intercepts and we move on. Why? How can you guarantee me this does have an x-intercept?
Because it goes like this.
Exactly. Look at the way the behavior has to be,
Across the
right?
X.
If it has to go down on the left and up on the right, what must happen? Must cross somewhere, right? Must cross somewhere. Unless it's just going to all of a sudden just like disappear and then come back over here. But then
That would be a different thing entirely.
it wouldn't be continuous, right?
It wouldn't be a function.
It would be a function.
I mean,
It just
be
wouldn't
continuous.
be a polynomial.
There you
Polynomials have to be drawn. All polynomials can be drawn without picking up your pencil. All of them. So if I've got to get from down here to up here and I can't pick up my pencil, I've got to go through the x-axis. There's no way around it. And so there's got to be a way for us to find the x-intercepts. There's got to be. Well, I hope there is, right? So we are stuck. Yes, we agree? We are stuck. It's going to take us a while to get to the actual method, okay? We have to go kind of slow with it, build up to it, but we will eventually be able to do that. Now let me convince you that it does work. I want us to take a look at x minus 2 times x plus 3 times x plus 7. I want us to look at those three factors right there. And I'm going to multiply them together. And that's what I did up here on the board. But just so everyone's clear on how this is done, if you ever have three binomials like this and you want to multiply them together, I always like to do these two first. So do like your little FOIL game on that, right? FOIL, this, 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 this. If you do that, you get that first line there, right? Or sorry, the second line here. That's what you would get. Y'all agree?
Yes.
Okay. And then you collect those like terms together and you'd get the third line here. And that's the line I'm going to put up here. How do you multiply a binomial times a trinomial?
The same way.
Same way, but not we don't use FOIL anymore, right? FOIL was cute, but it only works with 2 and 2, right?
I think it's still a distributed.
You're distributed. You're going to do here to here, then here to here, then here to here, then here to here, here to here, here to here. This is actually called expanding. Okay, that's called expanding. You could say distributing. Yes, that kind of makes sense too, but the more technical word for it is expanding. You're expanding this product out. So when you do x times x squared, you get x cubed. X times 10x, you get 10x squared. X times 21, you get 21x. So that's the first three of the second to last line. And then you go and do the -2 through, and then you get all that. You collect it all together, and voila, what is it at the end? It's the problem that we started with, right? Right? This is the one I asked you to factor, and we got stuck? Yeah? And I hope I just convinced you that this is this. If this and this are the same thing, our question is, how do you go from here to there, right? It can be, I mean, it factors, right? It definitely does factor, but we can't get to that. It's kind of hidden from us.
Well, I know there's going to be 3 x-intercepts.
Yeah, there's because of the power, right? But okay, so this is a big open question, okay? We are not ready to answer this. How we go from there to there. We are not ready for that yet. But that's where we're headed, okay? That's our goal is to be able to do this. So believe it or not, the way we're going to get this is by looking at division, the operation of division. All right, so remember that if you've got the good old classic 15/3 division, everyone goes, what's that? 5, right? Everyone says 5. Now, if we were to rewrite this a different way, what this is really telling us is that 5 times 3 is 15, right? What was the remainder here when we did this division? So now I'm going to go even further back. I'm going to go back to grade school when we did 15 divided by 3 like this. And you would say, okay, what do you multiply 3 by to get 15? You say 5, right? And you go 5, and then 5 times 3 is 15, and then you subtract, and then you get 0. Remember that? You go, oh, R0, right? And they put a little star on your paper. Remember the R? Remember that remainder? Okay, so if we have a remainder of 0, then it means that these two numbers multiply to be the top number, doesn't it? So let's go and think about it a little bit backwards now. If I were to be sitting here and I were to be talking to you about the number 15, and I were to be asking you, can you break 15 up into a product of two things? You could sit there and just go, oh yeah, sure, 3 times 5, right? Everyone, because we're all like past grade school, right? 3 times 5. But let's say you didn't know that. Let's say you actually didn't know it was 3 times 5. What you could start doing is taking 15 and start dividing it by numbers until you got a remainder of 0. So like we would never want to do 15 divided by 1 because it's just 15, but how about 2? Does 2 go in there? Well, 7 times 14 and 1, and you have a remainder of 1. No, that doesn't work. So then you'd go 15, you go to the next number, right? From 2, you go to 3, and you go and you do your thing, 5 and 15, you get a remainder of 0. And go, yes, 5 and 3 give you 15, right? Yep. I know this seems trivial, okay? This is exactly what we're going to do with polynomials. We're going to take a polynomial, and we are going to try and divide things into it until we get a remainder of 0. Once we get a remainder of 0, we know that whatever we divided into it and our answer multiply to be the polynomial we started with. And that basically breaks it down and factors it. That's the gist of what we're doing. You have to see it in action, all right? So let's take a look at this first example. X squared plus x minus 2 over x plus 2. And what I'd like to do here is I'd like to kind of highlight right here. Give me just a second. I'm expecting an important message. Let me just take this out here. Okay, got it. So imagine that this wasn't here. And the goal was to try and factor that. All right? And let's act like you have no idea. Then what I'm going to do, this is like me saying, here's the 15. And so what I'm going to do is I'm going to try and figure out how 15 breaks down. So I'm going to try and start dividing things into it, all right? And what number do we know will work? 3 will work, right? That's what we're doing here. I'm trying to take this and divide this into it, hoping that I would get a remainder of 0. That's what I'm hoping for. If I do, then I know that this is one of the factors. Understand? Yes or no? You understand?
Yeah.
Okay. So focusing all our attention on there. Now, before I divide that in, like old school, grade school division, let's use the fact that we do know how it factors to cheat a little bit to see what the answer is before we actually go get it. So how can you factor the top?
No, it's not.
X minus 1, x plus 2.
X plus 2. That's how the top factors, agreed?
Yeah.
The bottom is x plus 2. Do you see a common factor there?
Yeah.
You can cancel them. And so you get what? X minus 1. So this means that this should be x minus 1. When we're done, it should be, right? This should be this. And that tells us, so this tells us x squared plus x minus 2 equals these two multiplied. This is like the 3 and the 5 and the 15. Understand? So this tells us that x plus 2 times x minus 1 equals this. I hope you're getting this. We have not actually divided it. I just cheated to tell us what the answer is. Next question would be, let's act like we didn't know that. How would you divide that in, right? Okay, so let's actually do the division. And this requires what's called long division. What's wrong with, why do you hate it?
It's so
Why does everybody hate it? Because it's tedious?
long.
It's tedious?
Yes,
Okay. Nobody ever likes long division.
They should call it algebra.
In my Cal 2 class today, we had to do long division for something, and everyone had the same reaction.
If I just called it awesome division in the first place, then I think that people would have a little bit more of a positive influence.
Yeah, maybe. Maybe it's a psychological thing. You know, if they call it like sucky ass division, then everyone's going to think it's sucky ass division. You know,
Say long division.
say long, it seems right. So maybe. Well, the good news. There is a short division, but they call it synthetic division. So then you think it's like synthetic, you think it's fake. You know, so I mean, it's like, yeah, it's bad wording. Can't do anything about it. It is what it is.
Aren't really known for coming up with great names. You know?
That's right. You're right. All right. So our goal is to divide this, right? To try and divide and have a remainder of 0, right? That's what we are hoping for. So what we do for long division, and I could write the process down like in words, but it's most, excuse me. I think it's easiest to explain by demonstration, right? So you go back to grade school, you put your big long division bar there, and then inside here goes the numerator. So just like, remember when we had 15 over 3, the 15 goes in there, right? So you put x squared, you put plus x, you put minus 2. And then on the outside goes the divisor, which is the denominator, which is x plus 2. Also, make sure when you do this that everything is in descending order. So highest power of x down, highest power of x down. If you get them mixed up, it's going to throw everything off. All right? And then at this point, you do exactly what you did over here. Didn't you ask yourself how many times does 3 go into 15? Like, what do I multiply 3 by to get 15? So you're going to do the same thing here, except it's too difficult to try and figure out what you multiply the whole thing by. So all you have to look at is the x. What do I multiply x by to just get this first one? So I multiply x by x to get x squared, don't I? So what I'm going to do is I'm going to put x here, and I'm actually going to line it up above the x here, although that really doesn't matter. Some people are real particular about it. Like, if you're going to multiply, if you multiply this by x squared, then they would want the x squared here, but it doesn't matter. Yeah. So let's say up here, when we did 5, we then did 5 times 3 is 15, right? And put it down here. We're going to do the same thing here. We're going to do x times both of these. All right? So we're really doing like x times x plus 2. And that requires distribution. So the x is going to hit each of those. So x times x squared, and I'm going to put that underneath the x squared. Then I'm going to do x times positive 2, which is 2x. I put that underneath the x's. And then what did we do once we did 15 here? We came through and subtracted and got 0. Here we're going to come through and subtract, right? When you subtract, it changes the signs. Everything that used to be positive becomes negative. Everything that was negative becomes positive. So this becomes, instead of positive x squared, negative x squared. Instead of positive 2x, it becomes negative. So I just like exaggerate it really bad like that. And then you add down, just like you did 15 minus 15. So what happens here? X squared minus x squared. It's gone. That's what you want. Positive x, take away 2x, negative x. And then negative 2, and then take away nothing, or there's nothing here. So just minus 2 here again. And then we play the game again. We say, all right, try and turn this x into the piece that's left here. So how do you turn x into just the negative x? How do I turn x into negative x? Multiply by negative 1, right? So I put that up here. And then I have to take the negative 1 and pass it through to this one. So I'm going to do negative 1 times x plus 2. Distribute that to each of these. So what's negative 1 times x? Negative x. Put that underneath. Lining up. Negative 1 times 2, negative 2. Line it up. Questions? Yes?
Why can't we just use synthetic division?
Well, we don't know what that is yet.
Oh.
That's short division. That's our short division. Yes, we will. Yes, definitely we will use that. Okay, here and then subtract, right? Change the sign. So plus plus, add down and get 0. And that's the remainder. That's the remainder. And if the remainder is 0, which we're not going to write remainder, okay? I just want to kind of highlight this again. If the remainder is 0, then over here, when the remainder was 0, it meant that 5 and 3 multiply to be 15, right? That means that this and this should multiply to be this, right? So the answer to the division problem is what? The answer to this division problem is x minus 1. But what's more fundamentally important to us right now is that if we did not know how to factor the top, and we chose this correctly, and we get a remainder of 0, then this automatically told us that x squared plus x minus 2 would factor to be x plus 2 times x minus 1. And so we have factored it. Yes? I'll get to you. Where does what?
Oh, well, I just kind of got lost where you took the minus x squared minus, I love that. That one, where did that 2x come from? That came up
This x goes to this x becomes x squared. This x goes to positive 2 becomes positive 2x. Then we subtract the row and change the signs.
It's been so long since
Okay.
I've done this, though.
That's why I'm going through it like you've never seen it.
I haven't seen this since I was in elementary.
Your question.
When we're trying to factor, we're just going to have to like guess.
Okay, that's always the great question I hear is, let's say that you were asked to factor that, and you don't know how to factor that, which is what we stopped at, right? When we were stuck in that problem. Your question is, well, how do we know what to divide by? Are we going to just guess? And the answer is kind of. There's actually going to be a list of guesses that we are going to use. But see, the list that we create of guesses is still better than nothing, which is what you have now, right? You understand? You have, if I said, come in here right now and divide this by x plus a number or minus a number, how many possible numbers could you pick for there? Infinitely many, right? You could be here for the rest of your life and never get it. But this method that we're going to create is actually going to give us a list of possibilities. And the largest the list ever gets is like maybe 40 or 60 possibilities.
What? It's only 40 or 60, guys.
But then we get synthetic division. And synthetic division is a shortcut of this, and it goes faster. So you can knock out you can do like 10 tries per minute, as you get quicker with it. You just keep on going. You keep on looking for a remainder of 0. So, and I promise you that when we get to that point on a test, that when you're doing your test and doing this guessing thing and trying these numbers, that if you have a list of 40 possibilities, as long as you do them in sequential order, so like if you had like 1, 2, 3, 4, as long as you do them in that order, I promise that it will work within like the first 6 tries. I'm not going to make you try like 40 numbers on a test. Okay. Let's try something else. Let's try some other long divisions here. Just to see if we can get used to this method of this long, exhausting method. Let's do x squared. I'm going to do b. What did you say? E? Okay, so I'm going to do b first. So do y'all want to cheat a little bit real quick here and see, like, is this going to give us an answer?
I'd rather do that at the end.
You want to do it at the end?
I would rather do that.
Okay, then let's just try the long division and see if this will work.
Because when we did the first one, I was like, my brain's like, why didn't you just do that?
Okay, so again, this would be eventually someone saying, how do you factor that, right? And then you come up with this guess, which again, we don't know where that's going to come from yet.
You always said highest power leading down.
Down, yes. So I'm going to put x squared plus 2x minus 15. And then on the outside, I put x plus 4. Do you want to try that on your own?
Let's do this one together, then the next one.
Okay, that's fair. All right, so I'm going to multiply, I'm asking myself, what do I multiply x by to get x squared? X. Put that here. And then you multiply that x to here, get x squared. Multiply that x to here, get 4x. Line them up. And then don't forget to come through and subtract or change the signs. So minus, minus. If you write in pencil, then you can really make it a minus, you know. Question?
Oh, right, because you have to multiply.
Both of them. And then they drop underneath.
Just like with the distribution.
So what do I get when I add these rows down? Negative 2x. Then minus 15. So I go again, right? What do I have to multiply x by to get negative 2x? Negative 2. And then do the distribution again. So negative 2 times x is negative 2x. Negative 2 times positive 4 is negative 8. Come through, change the signs. Add down. What are you left with? Negative 7. Right? Yes?
So hypothetically, if I do know synthetic division, do I ever have to use long division?
Long division is more powerful than synthetic division. Hear me out. Because synthetic division can only be used when your denominator is a linear expression.
Okay.
If this is ever something other than linear, like E and F, synthetic doesn't work. So we just teach this so that you have a method for that. And then we say, if this is linear, we have a shortcut. So that's the part of it. Like you need to take Cal 2 or no? Cal 1? In Cal 2 today I did long division, and that's exactly, we had to do long division. We couldn't get around it because our denominator wasn't linear, so we had to do it this way. So it's just a matter of, you've seen it before, you know how to work with it, and when it creeps up again in another class, you're familiar.
Then what do we do with our remainder?
Okay, so is that a remainder? Well, you now have to try and turn x into negative 7, which you're not going to be able to do, right? So when do you stop the synthetic, sorry. When do you stop the long division? You stop it when the power on this is bigger than the power on what you're looking at. So remember when we were at this step, what was the power on this piece right here? What was the power next? 1? They were the same powers, right? When we started initially, squared was bigger than this. When this power gets bigger than this power, you have to stop. So
And then that's your answer.
this is my answer. This is my remainder.
And what do you
So,
do with
so
it?
what you do with it is you write plus the remainder, negative 7, over the divisor, plus 4, x plus 4. Now, I'm going to explain to you why in an example over here. Well, I'll show you the example after we conclude what we're going to conclude. What is the answer to this problem? What is the answer? It's x minus 2 plus negative 7 over x plus 4. Agreed? Yeah? That's the answer to the long division problem. We're done. But now let's get back to where we were trying to go with this. X squared plus 2x minus 15. My question to you is, does this factor to be two nice things like this? No, with x plus 4. Like, does x plus 4 work as one of its factors? No, it doesn't. Because when we try it, we get a remainder.